Hi, welcome back. In this video, we're going to talk about the vertical line test and how it relates to graphs of relations and functions. So our motivation here is prompted by the following question. How do we determine if a relation is a function by looking at its graph? So we're able to do this with tables by looking at all of the inputs and making sure they only have one output, but how do we do this graphically? So remember that a relation is a function if every input maps to a unique output. So this would mean that every x value, if x is our input, corresponds to at most one y value. Now let's look at a graph and see what this would look like. So if we have our x and our y axes, this would mean that we would have a point where there is one input corresponding to one output. But this might go wrong if we have one input having two outputs. So imagine another point that's in this vertical line. So the same input has multiple outputs. This would mean that this is not a function. So if it is a function, the input has only one output, so that x value corresponds to only one y. But if it's not a function, then that input has two outputs, and they'd show up sort of above each other in this line. So this is where the vertical line test comes from. The vertical line test says that if every vertical line touches a graph only once, then that graph represents a function. So if we can run a vertical line through the graph, and every instance of that vertical line only touches the graph once, then that graph represents a function. Let's practice this with some examples. So here are three graphs, and we'll practice the vertical line test with these. So the first graph is x squared plus y squared equals 1. This is the unit circle, called this because it has a radius of 1, and unit is a word that often means 1 in math, so this is our circle with radius 1 centered at the origin, called the unit circle. Then next we have f of x equals x squared. This is a parabola. And then we have g of x equals square root of x, and this is a square root. Okay, so let's try the vertical line test with each of these, starting with the unit circle. So if I take my vertical line and just run it through the function from left to right, you'll notice there are many places where the line is touching the graph in two locations. So this means that the unit circle is not a function. It fails the vertical line test because these vertical lines intersect the graph in multiple places. However, if we try this now with the parabola, you'll notice that every vertical line touches the graph only once. So it's always touching just once, whereas the vertical line on the unit circle is touching twice. So while the unit circle is not a function, the parabola is a function as determined by the vertical line test. We can repeat this again for the square root function. We can see every vertical line touches the graph or intersects it only once, and so this is also a function as determined by the vertical line test. And there we go. So we take that vertical line, we run it through the function. If you're doing this by hand, you can use a pencil or a piece of paper or something, and you just want to see, is that vertical line touching the graph in more than one location? So is there a place where there are two outputs for one input? And that would mean that the graph does not represent a function, but if a graph passes the vertical line test, then we can confirm that it is a function. Alright, and that is how we determine if a graph represents a function. Thanks so much for watching, and I will talk to you in the next one.